We are an enigma wrapped in the stars. Our very existence is one. Everything around us is, because nothing that exists should actually be there. So why, in a universe that physics says shouldn't even exist, do we breathe, think, dream? Why, amidst this infinite cosmic space, from the majesty of galaxies to the invisible dance of subatomic particles, does something exist rather than nothing? These questions ignite the spark of an unprecedented journey, an odyssey that leads through starry paths, beyond the boundaries of our understanding. Prepare to embark on an adventure that will change your view of existence. A journey that will profoundly alter your perception of everything around you and of infinite space. Think of the universe as a gigantic puzzle, a mystery wrapped in the vastness of space. Since we began staring into the night sky, we have wondered, where does all this come from? What does it mean to be a small part of such an immense cosmos? And more so, modern science brings us to an even more astonishing enigma. According to the rules of physics we know, the universe we live in shouldn't even exist. When we look at the stars, what we see is more than just a twinkle in the night sky. Each one is a piece of a puzzle that goes beyond our imagination. The laws of physics, with all their calculations and theories, have led to the understanding of many wonders of the universe. But there's a hitch. These same laws, when applied to the entire universe, tell us that something doesn't add up. It's as if the universe is a book whose first page is missing, a story that begins in the middle of a sentence. Why does the universe exist? This is a question that has challenged scientists for decades. Every galaxy, star, planet, and even every particle that makes up reality seems to follow a script written by the laws of physics. But the very fact that there is a script, that there is a universe to study, is a mystery that goes beyond comprehension. Current theories tell us that the universe had a beginning, the Big Bang. But why this beginning occurred, why there is something rather than nothing, remains one of the biggest mysteries of science. Prepare then to start an extraordinary journey through the greatest mysteries of the cosmos. From the infinitely small to the infinitely large. A journey that from the depths of the universe challenges all our knowledge. Imagine having a billion trillion lottery tickets in front of you. Among all these, you pick just one, and that is the winning ticket. This is the probability of the Big Bang, the beginning of everything we know. In scientific terms, it is an event with a probability of 1 in 10 raised to the power of 10 raised to 123. A number so large it far exceeds anything we can imagine. This extraordinary moment, the Big Bang, is the starting point of the universe, our grand and spectacular beginning. And as if that were not enough, life also exists in our universe. The conditions necessary for life to develop and persist are incredibly specific and delicate. From the force of gravity to the cosmological constant, from the distribution of matter to the formation of stars and planets, every aspect of the universe seems to be perfectly set to support life as we know it. This fine-tuning is considered by many to be an incredibly improbable, if not nearly impossible, coincidence. This is because the Big Bang is not just the event that originated the universe, but also the moment when the initial conditions for everything that followed were formed. These initial conditions included the distribution of matter, energy, temperature, and other fundamental physical properties. One of the most astonishing aspects of the universe is its ordered and coherent structure. The galaxies, star systems, and even the laws of physics we observe today are the result of these initial conditions. The question is, how likely was it for the Big Bang to produce such an ordered and structured universe? Roger Penrose used principles of thermodynamics and the theory of general relativity to calculate the probability of the initial conditions necessary for a universe like ours. His calculation was based on the amount of order, or low entropy, required at the beginning of the universe. Penrose arrived at the number of 1 in 10 raised to the power of 10 raised to 123 to describe this probability. To understand how small this number is, consider that the total number of particles in the observable universe is estimated to be much less than 10 raised to the power of 90. Thus, the probability calculated by Penrose is infinitesimally smaller than any number we can observe or imagine in the universe. This improbability challenges our understanding of the universe's origin. If the initial conditions were so unlikely, how is it possible that the universe exists in the form we observe it? This leads to deeper questions about the nature of the universe and physical theories. Is there something missing in our current model of the Big Bang? Are there principles or physical laws yet to be discovered that could explain this improbability? The problem of the fine-tuning of the universe is one of the most intriguing and debated topics in physics and cosmology. It concerns how the fundamental constants of the universe and the laws of nature seem to be incredibly calibrated to allow the existence of life and matter as we know them. Gravity is one of the 4 fundamental forces of nature. Its intensity determines how matter aggregates to form stars, galaxies, and other celestial bodies. If gravity were slightly stronger or weaker, stars might not form correctly, or burn too quickly or too slowly, making the development of life as we know it impossible. The cosmological constant is a value that determines the rate of expansion of the universe. If it were too high, the universe would have expanded too rapidly to allow the formation of galaxies. If it were too low, the universe might have collapsed in on itself, long before any complex structures could form. The electromagnetic force plays a crucial role in chemical reactions and the formation of atoms. A small variation in this force could make the formation of stable atoms impossible or disrupt the chemistry necessary for life. These constants and forces are so finely tuned that even minor variations could make the universe completely different, likely unable to support life. For example, a 1% variation in the strength of gravity could prevent the formation of long-lasting stars, essential for the development of life. A slightly different cosmological constant could have led to a universe where matter never aggregated into galaxies. Minimal changes in the electromagnetic force could make complex chemistry necessary for biological structures impossible. The fine-tuning of the universe raises fundamental questions. Is it possible that this precise balance is merely a random result? Or does it suggest some sort of necessity or design in the universe? Some scientists propose the multiverse theory, according to which many universes exist with different laws and constants. In this scenario, our universe would be just one among countless others, and its fine-tuning would be less surprising. Our universe would simply be one of the many where things happen to work out right. The improbable likelihood of our universe's existence has prompted scientists to search for new laws of physics. that could explain fine-tuning as a natural necessity, rather than an incredible fluke. Scholars are working to find answers to these questions. But the mysteries of our universe are far from over. Imagine a moment when everything we knew about the universe changes radically. This moment comes with Albert Einstein, one of the greatest geniuses of physics. Einstein revealed a surprising secret: mass, the substance that objects like stars, planets, and even we are made of, and energy, the force that powers everything, from sunlight to the movement of galaxies, are actually two sides of the same coin. This revolutionary idea is encapsulated in his famous formula: energy equals mass multiplied by the speed of light squared, which opened a new window onto the universe. But the story doesn't end there. After Einstein, scientists began to discover that what we see of the universe, stars, galaxies, planets, is just a small part of a much larger picture. Much of the universe is composed of something we cannot see or touch: dark matter and dark energy. Dark matter is like the invisible thread that holds galaxies together, while dark energy is a mysterious force that pushes the universe to expand ever faster. These two invisible entities silently dominate the universe, guiding its behavior and structure in ways we are still trying to understand. Think of the universe as a gigantic ballroom, where every star and every galaxy dances in an intricate waltz. But this dance is not guided only by gravity and the laws of physics we can see. It is also orchestrated by these invisible forces, dark matter and dark energy, that pull the strings behind the scenes. It's a cosmic dance on an unimaginable scale, with galaxies twirling in an ever-expanding universe, under the guidance of these mysterious forces. Today, scientists are like cosmic detectives, trying to unravel the secrets of these invisible forces. Every new discovery brings us closer to understanding the true face of the universe. The search for dark energy and dark matter is a journey to discover our place in the universe, to understand how and why we exist in this vast and mysterious cosmos. Imagine being in a place so empty that it contains nothing. No stars, no planets, not even a speck of dust. You might think that in such a place there is no energy, right? Surprisingly, even in this cosmic void hides a mysterious type of energy: vacuum energy, also known as zero-point energy. This vacuum energy comes from something truly extraordinary and difficult to imagine. In the deepest void of the universe, there exist tiny particles, called virtual particles, that appear and disappear in the blink of an eye. These particles are like ghosts of the universe. We cannot see or touch them, but they are everywhere, even in the most complete void. These virtual particles are never still. They continue to appear and disappear in an endless cycle that occurs in fractions of a second. This constant movement creates a type of energy that is present throughout the universe, even in its emptiest and darkest corners. It's as if, even in the most absolute nothingness, there is a ceaseless dance of energy. Vacuum energy is one of the most fascinating and mysterious topics in modern physics. Scientists are still engaged in trying to fully understand how it works and what effects it has on the universe. This subtle, yet powerful energy might play a crucial role in how the universe behaves, in its ultimate fate, and even in the mystery of the universe's accelerated expansion. Vacuum energy confirms how little we still know about the universe. Every discovery in this field opens a new window onto the infinite. This journey in search of answers shows us how vast and astonishing the universe we live in is, a place where even nothingness is full of life and energy. Now, imagine stepping into a world where the usual rules no longer apply, a world where everything is possible and nothing is certain until you observe it. Welcome to the realm of quantum physics, a place where the universe presents itself as a vast mosaic of possibilities and uncertainties. Here, the smallest particles of the universe, such as atoms and their components, do not follow the laws of classical physics we know, but dance to the rhythm of completely new and astonishing rules. Physicists like Werner Heisenberg and Wolfgang Pauli were among the pioneers in exploring this extraordinary world. They discovered that in the microcosm, the very heart of reality, we can never be completely sure of what will happen. For example, if we try to measure exactly where an electron is, we lose the ability to know how fast it is moving, and vice versa. This is the famous quantum uncertainty, a fundamental characteristic of the subatomic world. In this quantum universe, everything is a matter of probability. Particles exist in a sort of fog of possibilities until they are measured or observed. It's as if each particle is in many places at once, exploring all possible paths until we decide to look. At that moment, as if by magic, it chooses a definite position. This concept challenges our intuition, but is key to understanding the behavior of atoms and molecules. Quantum physics is not just about explaining the behavior of microscopic particles. It also has immense implications for the larger questions of the universe, such as the nature of dark energy. This mysterious energy, accelerating the expansion of the universe, might have its roots in the laws of quantum. Discovering how the laws of the microscopic world influence the cosmos on a grand scale is one of the greatest enigmas that modern science is trying to solve. Exploring the quantum world is like embarking on an endless journey into unknown and fascinating territory. Each new discovery opens a window onto an even more extraordinary and complex universe than we could have imagined. This journey into quantum physics shows that, at the heart of our universe, lie infinite mysteries that challenge our very concept of reality. Imagine a cosmic mystery so vast that it challenges the understanding of the brightest minds for nearly a century, an enigma lying at the very heart of the fabric of the universe. This is the mystery of the cosmological constant, also known as the weight of the universe. On one side, we have quantum mechanics, describing the bizarre and unpredictable world of subatomic particles. On the other, Einstein's general relativity, painting a picture of gravity as the curvature of space-time caused by mass. When these two theories meet, an astounding paradox emerges. According to the equations of quantum mechanics, the energy contained in the vacuum of space, yes, even nothing has energy, should be immense. This vacuum energy, according to general relativity, should influence the gravity of the universe in such a way that it would collapse under its own weight, just like a massive star imploding into a black hole. Instead, we look out and see a universe that not only resists this collapse but is expanding. And not just expanding, but doing so at an increasingly faster rate. It's as if a balloon, instead of bursting when overinflated, starts to inflate even faster. This observation has led scientists to reintroduce Einstein's cosmological constant, but in an entirely new context. Instead of being a force that keeps the universe static, it might be the key to understanding this acceleration of the universe's expansion. The fundamental question is, why is the cosmological constant so finely balanced to allow the universe not only to exist, but also to expand in this way? Is it a fortunate coincidence, or is there a deeper explanation that still eludes us? Solving this mystery might require new physics, a theory that can elegantly unite quantum mechanics and general relativity. It could even lead us to a greater understanding of dark energy, that enigmatic force accelerating the expansion of the universe. After a fascinating journey through the wonders and mysteries of the universe, it's time to draw the threads together and reflect on what we have discovered. We started with the unthinkable probability of the Big Bang, the event that gave birth to everything we know. This initial moment, so precise and finely tuned, laid the foundation for the very existence of the universe. We then traveled through Einstein's physics, discovering how his revolutionary equation, m2 unified mass and energy, revealing a universe where dark matter and dark energy played dominant but invisible roles. In the deepest void of the universe, we discovered the existence of a subtle but powerful vacuum energy, showing that even nothingness is not truly empty. In the realm of quantum physics, we saw how the universe manifests as a mosaic of probabilities and uncertainties, with laws that defy our everyday intuition. Finally, we grappled with the enigma of the cosmological constant, a mystery that underscores the vast discrepancy between theories and observations about vacuum energy. This issue opens a window onto still unresolved problems, continuing to stimulate our curiosity and thirst for knowledge. This journey through the universe reveals a landscape rich with mysteries yet to be unveiled. Each discovery brings new questions. Each answer opens new horizons to explore. We have witnessed the grandeur and complexity of the universe, a place where every particle, from those in the deepest void to the stars in the farthest galaxies, plays a role in the grand cosmic scheme. Reflecting on all this, we understand that we live in a cosmos that, against all odds, not only exists, but continues to evolve in ways we are still struggling to fully comprehend. Understanding the universe is perhaps the greatest challenge we can face. A universe that remains a mosaic of mysteries and wonders. And we are the fortunate explorers of this infinite space of discovery. There would be much more to say, but for now, let's pause here. We will soon return with new mysteries of the cosmos. Let us know in the comments what you think. And if you love getting lost at the edges of the universe, subscribe to the channel to not miss the new videos until the next journey.